So if we did d over dx of f over g of x, or we could say d over dx of f of x over g of x. With product rule, your f and your g could switch, right? You could go f times g, you could go g times, like it doesn't matter. I always do f times g, but you can do it in any order you want, because product rule, 2 times 3 is the same as 3 times 2. But with division or quotient rule, your denominator is always g, your numerator is always f. Your denominator is always g, your numerator is always f. Okay? When you use that, the formula for it, I don't know why I have an equal sign in here. The formula for it is gf prime minus fg prime. Do you see why I wrote it the other way, product rule? And then it's over g squared. And people will forget to put the denominator on it half the time because you'll have done all this work and then no g squared. So that's not good. So, do these. Let's just do this one. Example 1.
All that on podcast.
So we still have our f and g like normal. This is our f, this is our g. What is our f prime?
2x plus 3.
2x plus 3.
I was going to say that constantly.
And then g prime?
12x squared minus 4x.
And that's it, right? So then we're doing y prime. Y prime equals g times f prime minus f times g prime. And people will often forget to go like this. Divided by 4x cubed minus 2x squared plus 6 squared. They do not expand this out, just so you know it'll stay like that. Don't go distributing.
Will we usually not need to distribute, or is that just?
No, you don't have to distribute.
I like that a lot better.
Because often we'll try and cancel them off. Okay, you try and see what you take out for GCF. And often when it's polynomials, you actually can't take anything out, but this one you can. If you're stuck and you're like, I don't think I can take anything out, you could still FOIL or distribute, collect like terms, and then see if there's a GCF you can take out of every term. So it's not the end of the world, right? So I know in this bracket 2x plus 3, there's nothing I can take out. This one I could take out an x. However, there's no x's to take out of here. This one I could take out a 2. This bracket, I could take out a 2. Remember, this is one whole term. This is one whole term. So this bracket, I could take a 2 out. And this bracket, I could take a 2 out. Correct? So I could technically, if I wanted to, I could write this as 2, a bracket 2, 2x cubed minus x squared plus 3 times 2x plus 3. I would do this in a second step, but I'm just proving a point. Minus x squared plus 3x times 2. So then they technically both have a 2 in a bracket, right? That's why I can take the 2 out. This term here has a 2 in a bracket. This term here has a 2 in a bracket. So I'm going to get 2, and then what's left over is 2x cubed minus x squared plus 3 times 2x plus 3 minus x squared plus 3x times 6x squared minus 2x all over 4x cubed minus 2x squared plus 6 squared. Then I have to distribute. So I'm going to get y prime equals 2. And in my square bracket, I'm going to get 2x to the 4. That's why. 4x to the 4. And then 6x cubed. And then negative 2x cubed. Negative 3x squared. Plus 6x. Plus 9. Minus in brackets, and I have to put in brackets because I'm going to FOIL those two brackets, right? But I still have to distribute the minus sign through. So I'm going to get 6x to the 4 minus 4x cubed plus 18x cubed minus 6x squared all over. Is it 2x cubed? I don't know. Because it's so long to write it out too, I'm not going to do an extra step. I'm going to go change this to a plus, change this to a minus, change this to a plus, change this to a minus, change this to a plus. And then I can just collect like terms, right? So y prime equals 2. And then in the bracket, I have 4x to the 4 minus 6x to the 4 is negative 2x to the 4. And then I get 6x cubed minus 2x cubed is 4x cubed. Plus 2x cubed is 6x cubed. Minus 18x cubed is negative 12x cubed. And then I get negative 3x squared plus 6x squared is positive 3x squared. And then plus 6x plus 9. Now, if you had not taken out the 2, not a big deal. You would have negative 4x4 minus 24x cubed plus 6x squared plus 12x plus 18, and you realize you take a 2 out. It's not a big deal, right? So when it's a polynomial over a polynomial, you can GCF at the end once you've collected all your like terms as well. And then we get 4x cubed minus 2x squared plus 6 squared.
Why don't we also FOIL that one?
Pardon?
Is there any reason we don't also FOIL the denominator?
Because it's going to make it bigger, not smaller.
Then we also
You would FOIL it out and then you have to factor it back.
then we also take a 2 out and cancel it to an account.
2 out of the where?
To the denominator.
No, it's squared.
The 2 would still be under the square.
Yeah, you still have to like actually square that, collect like terms, then try and take a 2 out.
Or you could take out 4 and 5 perspective, right?
Yeah.
You could take it out of one bracket. You could do all that. There's not going to write the answer like that. Those are options, which you could do. You could write it as 2 brackets, take a 2 out, cancel the 2 off. They're not going to be as concerned about that 2 because when we get to the next unit, it's critical numbers, and critical numbers come from x's. So that 2 is just literally an extra number. That's not going to give us anything. It changes. It's a vertical stretch, right? So it would change your y, but it's not going to change your x's. Okay. Example 2. You guys try this one on your own. It's nicer.
Did you make up that first one?
Yes. Okay. Y equals x squared plus 1. I always make up harder ones and then give you the nice ones. At 2x minus 2. Find y prime. So, this one is f. This is g. F prime is 2x. G prime is 2. So we're going to get y prime, or dy over dx, equals g, 2x minus 3, times f prime, which is 2x, minus f, which is x squared plus 1, times g prime, which is 2, all over g squared. So we could take a 2 out of it, but I'm going to prove that if I don't, it doesn't matter because I can take it out at the end. Okay? We could take a 2 out. We take a 2 out of both of those, but I'm going to prove, don't matter. So I'm going to get dy over dx equals 4x squared minus 6x. And then I'm going to get negative 2x squared minus 2 all over 2x minus 3. You can either distribute the 2 in and then distribute the negative in. I just distributed the negative 2 in. I see a squared. I don't know what you're talking about, David. It's been there the whole time. Clear. I know. Maybe move closer. Okay, so we have dy over dx equals 2x squared minus 6x minus 2 all over 2x minus 3, and now, squared, and now if I did not take the 2 out, I could still take it out. So I'm going to get dy over, oh, this board. Okay, shh, quiet please. Dy over dx equals 2x squared minus 3x minus 1. Can that factor? No. Can the 2 come out of the denominator?
No.
No. We done. Okay.
That was so awkward.
It was amazing. I don't know what you're talking about. Next time, standing ovation would be preferred, but the clap was all right. Okay. What if I ask you for more than just the first derivative? Actually, I'm going to do something first. What if I give you this? Y equals 1 over x squared plus 3x. I'd like to make it better. What if I ask for this? I'm actually showing you something early. Now it's a 4.
Okay.
Because I'm a rebel without cause. I added a 4. Do I have to do quotient rule?
No.
No, there's actually this thing called chain rule. You haven't got to it yet. But I'm going to show it to you anyway. Because I'm going to show it to you in this instance. So in this instance, we have f over g, and we could do quotient rule, correct? This is a special case, though, where you do not have to do quotient rule. And the reason why that is because our numerator is a number. You see it doesn't have a variable? If our numerator has a variable, even if we move our denominator up, we're going to have to do product rule. So we're just moving from quotient to product. It doesn't matter, right? But if our numerator is a number, so this is what only you can do this when your numerator is a number. When that happens, you can move the denominator up. By raising it to the power of what? Yes. The whole thing though, right? And do chain rule. Okay, showing you something early because I think you'd find it fun. And we kind of did chain rule already with e's, which we weren't supposed to do yet either. But just teaching e to the x is boring and not true. It is true, but it's true because of what you do. Chain rule to get e to the x, and it bothers me to teach it that way. It's just e to the x, e to the x, derivative. Because the knowledge is not there. You're just memorizing. Memorizing drives me crazy. So I don't like bio. I didn't realize in high school that I could have just tried to understand it. I just went sheer memorization route, which is not the best way. You should really try and understand it. It makes it substantially better. All right. So we can't just take these and make them both negative. We can't just go x to the negative 2 plus 3x to the negative 1, correct? Because you can move the entire denominator. So if it was a monomial, like one term, you could move it up to the negative. But when it's more than a monomial, you have to say, okay, well, this is the power of 1. If I want to bring it up, I have to write it as 4 times x squared plus 3x to the negative 1. Now, we did chain rule with e to the x's, correct? We did the outside, and then you have to do the derivative of the inside. With e's, we wrote it, we lonned it, then we did the derivative of the exponent, because that's what you have to do when you have a numerical base to a variable exponent, correct? Chain rule, it always seems so overwhelming, but it's really not. You just work yourself from derivatives from outside in. That's all you do. So it's really just a power rule with extra crap on the inside of the power rule. That's all it is. So like a power rule is like 4x squared, right? What's the answer to that? Well, it'd be 16x, right? 4x squared, the derivative of that is 16x, yes? So it seems like it's substantially worse, but it's just
8x.
What is it? 4x squared is 8x, yeah. I don't know why I have to look at the board. I didn't write anything down. It's 8x. Because you take the exponent, you drop it in front, you multiply it, reduce it by 1, correct? Same thing here. There's a power rule. There just happens to be some stuff in the bracket. So we just ignore the stuff in the bracket first. That's all we do. So we do the outside. So if it was, in this case, if we had 4x to the negative 1, what would our derivative be? Just 4x to the negative 1.
Negative 4x to the negative 2.
It would be negative 4x to the negative 2, correct? Our x just happens to have a whole bunch of stuff in it. And by a whole bunch, I mean 2 terms. That's okay. So we would still do the same thing. The negative 1 drops in front. We get negative 4x, which happens to be 2 terms, to the negative 2. Do you agree? I just did power rule with that bracket. Did I not? Nothing crazy. It's called chain rule because you get chains behind it, right? Chains of information. Okay. What have I not done the derivative of yet? The inside, correct? So now I just get a chain behind it of the derivative of the inside. That's it. And if I want it to match the quotient rule answer, what's going to happen? This negative exponent is just going to go to the denominator as a positive exponent, so I'm going to get negative 4, 2x plus 3 over x squared plus 3x to the 2. Way faster than doing product rule. You could do or quotient, yeah.
So why are you doing power rule and then taking the derivative and multiplying it? Why does that work?
Because it's chain rule, that's why you have to do it. Because we can't do, when you do a chain rule, when you do the derivative of anything with something inside, you're still having to do power rule, there just has to be something inside, correct? So you can't, so what people try and do with chain rule often is they'll do the derivative of the outside and then try and do the derivative of the inside right away and slide it in there. You can't do that. You have to do power rule first. You always have to work your way from the outside in. So you have to do power rule first because that's the outside. Rewrite the bracket. And then you have to always, when you're done doing the derivative of something, derive everything. So we haven't done the derivative of the inside, so that's the chain behind it.
Okay, and how's that linked to the chain rule that we've done?
With the E,
Yeah.
it's a different chain rule because E chain rule.
There's two chain rules.
No, it's chain rule is you have to derive everything in the end. But the chain rule we did with E was we used the rule of E. When you do a base to an exponent, you have to rewrite it along the base and then derivative of the exponent. We just keep chaining when the derivative of the exponent actually has more derivatives. Like if the exponent was just x squared, then we just do 2x and we'd be done. But we had to keep chaining when we had e to the x squared because to the derivative of the e to the x squared is rewrite it on the base. Derivative of this one, oh crap, there's more. Like, so it's just because it kept chaining that way.
So chain rule is just derivative of everything?
Yes,
Multiply all
driving everything in the end from outside in.
Okay.
Most chain rule follows this type. E to the numerical base to the variable exponent follows the other type. So there kind of is like two main chain rule types. Yeah. So we could have just went F, G, and then done G, F prime minus F, G prime over G squared, and we get the same answer. It would have done the same thing. Okay, another example. I don't remember which this one is. 4. So I'm going to give you y equals 1 plus x squared times e to the x, and I want the second and third derivative. So I'm going to use both notations the whole way along. So sometimes it's y prime, sometimes we use this notation. You have to be able to use both. When you go to a prop, so they usually pick one that they like. And it depends on the person. So I want first derivative, and then I want second derivative. So what are we going to have to do here to get the first derivative? Product rule. Try it out. Make sure you take out GCF so that you can do the second derivative properly. So we have that G. So y prime equals G times f prime, which is 2x, plus f times g prime. Do you now see why I stuck with gf prime plus fg prime? Because if you do it in the order they do it, then people get them all mixy-mixied. It gets a little scary. So what can I take out of here?
E to the x.
The moment you have an e to the anything or a 4 to the something or a pi to the something, you can always take that out because your first step taking the derivative of that is rewriting it. Yes? And then I'm left with 2x plus 1 plus x squared, and I'm going to be a rebel, and I'm going to leave it like that, and it's going to drive you crazy because it's not in order from increasing to decreasing.
Yeah.
Yeah. And then we get, sorry, this should not be y prime. Who am I? A rebel? It's dy over d.
You are a rebel, apparently.
This board's a rebel. It even shot all the way up to the top. Dy over dx, which is what it asked for. Okay, then we have d2y over dx squared, and it's going to be g f prime plus f g prime. That's the way they write it.
Why x squared?
They write it that way. I don't know why I have square brackets, because I have one, I'm not erasing it. I'm putting another one. The square brackets are not needed, but I'm lazy and I'm not erasing it. Okay, so you can take an e to the x out, and we're left with 2x plus 1 plus x squared plus 2x plus 2. And so we get e to the x squared plus 4x plus 3. Is there anything else we could do?
Yes.
What?
I mean, you can exactly factor.
Yeah.
Or not basically, should we do that?
You should factor it if you can, yep. Because this will get us all of our critical numbers for next unit. We're going to set each of these equal to 0 and solve.
Using standard.
Okay, so your homework once again is section 2.4. Remember all those things I assigned yesterday and said you couldn't do them? Well, looky out today, because you can.
Yeah.
Thanks, guys. Thanks. Okay, so we'll do the AP practice problems first.
I actually have done something, but yeah, yesterday. Shockingly. Oh, look, I just put an answer because I didn't know how to do it. I knew how to do it.
Okay, AP practice problem. If I ask for instantaneous rate of change, we're going to write this down. Instantaneous rate of change. All that is the first derivative at that x value. So it's f prime at a specific x. So, for example, for AP practice problem 1, it asks for what is the instantaneous rate of change at x equals negative 2. So what you do is you find the first derivative using quotient rule, and then plug in negative 2 for the x's. So it wants f prime of negative 2, technically. So instantaneous rate of change at x equals negative 2 is just f prime of negative 2. So you find f prime first, plug in negative 2. That's all it is. That comes up a lot. Instantaneous rate of change. Instantaneous rate of change. Rate of change is just slope, right? Rise over run, that's a rate of change. So instantaneous rate of change is a rate of change at a specific instant. In this case, negative 2. They want an equation of a tangent line to a graph for number 2. So this is number 1 was the instantaneous rate of change. Number 2, they want a tangent line to a graph at 3, 4. Well, how do I get a tangent line to a graph? I have to find the tangent slope. How do I get the tangent slope? First derivative, plug in the 3 in this case, get your tangent slope, and use your x1, y1 into the equation and get your equation. It's nothing different. It's just not power rule now. It's quotient rule to get the tangent slope. Okay? That's number 2. I like numbers. Number 5 is just a product rule. It just gives you like t squared minus 1 over t squared. So 1 over t squared, guys, how can we write that so we can do that? Just t to the negative 2. And then just use power rule. Okay? Don't do quotient rule on that. Please, don't do quotient.
Yes.
Okay, and then your problems that you have to do are you can just wait it. You guys will get your tests back tomorrow. Just so 24. $26. 38. 40, I'm going to put a line under it because on 40 it has this. 40 has f of x equals x e to the x over x squared minus x. So I'm going to have to do quotient rule no matter what, right? I have to do quotient rule. It's a no-brainer. That has to happen. So this is my f, and that's my g, correct? What's the catch with this one? Yeah.
If you take an x out of the bottom, you can cancel out an x on the top of that.
You can take an x out of the bottom and the x out of the top and cancel it. What if you don't do that?
Still good.
What do you have to do for f? Product rule. So f prime is going to be a product rule. I want you to try it that way anyways, and you can do it, I want you to do both. So f prime would have to be actually g f prime plus f g prime. So it would be e to the x 1 plus x. And then your g prime would be normal, 2x minus 1. And then you fill in g f prime minus f g prime over g squared. So if your f or your g has a product in it, multiplication, you have your f prime is a product rule. So sometimes you have product rules embedded in quotient rules. Okay, sometimes you have chain rules in quotient.
Don't worry about it.
Hunter's fading away.
I'm very tired.
And then I want you to do 53. That's it.